Okay, so we're going to solve some trig equations. There's going to be four main methods that we look at: linear methods, zero factor property, quadratic methods, and equations involving half and double angles. To start with, we're going to do linear methods. So linear, remember that linear means we don't have any powers. So notice that I have sine to the first and cosine to the first. Okay, so we can solve this using linear methods. The other thing to notice is I only have one term, sine, cosine. I don't have multiple sines, sine squared, things like that. In that case, what we can do to solve these is we're going to isolate the trig term. So in this case, I'm going to isolate the sine. I can do that by adding 2 to both sides. So I end up with sine of x equals -3 plus 2 is -1, -1, okay? And now I can solve. Now for solving these, we're going to try two things. One, we're going to try and use our unit circle. That's if we're going to get an exact answer, okay? To get an exact answer, we're going to use our unit circle. And remember what this is saying. This is saying sine of some angle equals -1. Another way of asking this is, for what angle is sine equal to -1? Now the answer is there are many angles that this is true for, because remember we can think about coterminal angles. But notice, when we have a trig equation, we often have something like this. This says x is going to be between 0 and 360. So when we're looking at our answers, we're not going to have any degree measurements bigger than 360. We're not going to have any degree measurements less than 0. Okay, so let's go to our unit circle real quick. So I'm going to share our unit circle. Okay, here's our unit circle. Now we want to know for what values of x, for what angle measurements, is sine equal to -1. Well, remember, in terms of our unit circle, it goes cosine, sine, alphabetical order. So we're looking for -1 in y, which is right here. So here, at 270 degrees, or 3 pi over 2, we know that sine of 270 is -1. Okay, so our answer is x equals 270 degrees, because sine of 270 degrees is equal to -1. Now notice that 270 is in the interval that I need. It's between 0 and 360. Also notice that I gave my answer in degrees because my interval was given in degrees. Okay, let's look at the next example here. Okay, so now the next one, 2 cosine theta -3 equals -5. Again, this is linear because I just got that single cosine term and it's not squared or anything like that. Okay, so I can solve this by solving for that cosine term. So I'm going to add 3 to both sides. That gives me 2 cosine theta equals -5 plus 3, which is -2. Dividing both sides by 2, I get cosine theta is equal to -1. Okay, similar to this. Okay, we had sine x equals -1. Now we have cosine theta equals -1. So again, we're going to think about this. We're going to use our unit circle and ask ourselves, for what theta is cosine equal to -1? Okay, so let's go back to our unit circle real quick. So on our unit circle, remember that cosine is our x value. We're looking for -1 in the x value. That happens over here at pi, or 180 degrees. Now technically it would also happen when I went all the way around, so at 3 pi, and again at 5 pi, right? Because that coterminal angles would always end there. But we're going to restrict ourselves to pi. How do I know? Well, again, I look at this here. This tells me that theta has to be between 0 and 2 pi, so 1 revolution of the circle. The fact that this is 0 and 2 pi tells me that my answer should be in terms of radians. So theta equals pi. Let's work a couple more examples like this. All right, here's a couple more examples for us. So the first one, we have 3/4 tangent of x minus 1/2 equals -5/4. So again, our goal is going to be to isolate this single term and then see what we can figure out using our unit circle. Okay, there's a couple of different ways to work this problem. You could start by adding 1/2 and then dividing by 3/4. But personally, I would probably clear the fractions first. So what does that mean? Well, that means I notice that I've got a term whose denominator is 4, one whose denominator is 2, and another whose denominator is 4. The common denominator between 2 and 4 is 4. So I'm just going to multiply both sides of this equation by 4. Remember when I'm doing that, I'm not breaking any rules. So 4 times 3/4 tangent of x. The 4's would cancel, and I'd just be left with 3 tangent of x. 4 times negative 1/2. I have to distribute this 4 to both terms on this side. 4 times negative 1/2 is negative 2. Negative 5/4 times 4, the 4's cancel, and I'm just left with negative 5. Now I'm going to go ahead and isolate this tangent of x term. Okay, so I'm going to add 2 to both sides. So I get 3 tangent of x equals negative 5 plus 2 is negative 3. Divide both sides by 3, and we get tangent of x equals negative 1. So again, remember what we want to do. We want to look at our unit circle and think about where is tangent equal to negative 1. In order to do that, it's going to be helpful for us to remember that tangent is the same thing as sine over cosine of x. In order for this sine over cosine to be equal to negative 1, we need the value of sine and cosine to be the same. So these guys need to have the same value, but one needs to be positive and one needs to be negative. So let's take a look at our unit circle and see if we can figure out where that happens. Okay, so remember we needed sine and cosine to be the same. That happens at these pi over 4 values. Okay, these kind of middle angles in each quadrant. But additionally, we need for one to be positive and one to be negative. That happens here at 3 pi over 4 and also here at 7 pi over 4. So our answer is going to be 3 pi over 4 and 7 pi over 4. So this is satisfied when x equals 3 pi over 4 or 7 pi over 4. So two answers. Oh, but look, I screwed up. Why did I screw up? These are our correct answers. But notice this, our interval, is given to us in terms of degrees. So do we want this? Do we want these in terms of radians? No, we want them in terms of degrees, right? So in terms of degrees, what will we have? We'll have 150 degrees and 315 degrees. So our answer is when x is 150 degrees or 315 degrees. Okay, all right, let's do another one here, just a second. Okay, so when we look at the second one, you may be saying, hold on a minute, that's not linear, it has a squared term, and technically you are correct. This is technically not linear because it does have a squared term here. But because the squared term is the only term, there's no other trig term in here, we can treat this linearly. What do I mean by that? Well, just like we did for all our other examples, we're going to solve for this term in here. So I'm going to add 2 to both sides. So that gives me 3 times secant squared equals 4. And then I'm going to divide both sides by 3. So I get secant squared equals 4 over 3. Now from here, I want to get secant by itself. I can do that by square rooting both sides of my equation. That gives me secant of x equals, be careful here, when we take a square root, we get a positive and a negative. So secant is going to be equal to positive negative 4, square root of 4 over 3. Square root, I can do square root of top, square root of the bottom. So this is going to be positive negative. Square root of 4 is 2 over square root of 3. Now, technically I could rationalize that, but remember what we're trying to do. We're trying to figure out the angle such that secant is equal to positive or negative 2 over the square root of 3. Now, our unit circle doesn't technically have secant on it. Our unit circle technically shows us cosines and sines. We can then calculate everything else. But what do we know about secant? We know that secant is 1 over cosine. In other words, secant and cosine are reciprocals, which means, right, if secant is positive negative 2 over the square root of 3, cosine, its reciprocal, is going to be equal to the reciprocal of that, positive negative square root of 3 over 2. This is something we can look up directly on the unit circle. So we're going to go to our unit circle and we're going to look for places where cosine is equal to positive or negative square root of 3 over 2. So let's look at our unit circle. Okay, cosine is our x term. We're looking for square root of 3 over 2. So here's square root of 3 over 2 at pi over 6. Here's negative square root of 3 over 2 at 5 pi over 6. Here again is negative square root of 3 over 2 at 7 pi over 6. And finally, here again is square root of 3 over 2 at 11 pi over 6. So we have 4 different solutions for this guy. Okay, what are those solutions? Well, we saw that we got solutions when our x was in the first quadrant. We had 5 pi over 6. In the second quadrant, we had 7 pi over 6. Sorry, I missed the first quadrant. This is the second quadrant. This is the third quadrant. What was I thinking? In the first quadrant, we just had what? Pi over 6. Okay, and then in the fourth quadrant, we had 11 pi over 6. So we get 4 different answers for this one because of that positive negative that's popped out by the root. Okay. All right, the last thing I want to do is I do want to do one example where we have a linear function where our answer is not going to be exact. In other words, we're not going to get something that falls in our unit circle, and we're going to need to use a calculator to calculate that for us. Okay, so this last example, like I said, I want to do one where we're not going to get an exact answer, we're going to get an approximate answer, and I'm going to need to use my calculator to do that. Okay, so this is still linear. I've got one term here. And I'm going to start, just like we did our other examples, by solving for that sine term. So I'm going to add 2 to both sides. So I'll have 4 sine theta equals 3. And then I'll divide by 4. So that gives me sine of theta equals 3/4. Okay, now there are a couple of things that I could do here. I could try to split this into things that I know and then use some combination of half angle, double angle, etc. But the fact that this says round to the nearest tenth tells me I don't need an exact answer. I'm okay to do approximations. If I'm okay to do approximations, then I'm okay to use a calculator. To use a calculator on this, we need to undo the sine function. Well, undoing the sine function is literally using the inverse or arc sine. So I'm going to take the arc sine or inverse sine of both sides. I'm doing the same thing to both sides of my equation. I'm good to go. An inverse and the function cancel each other out, so I'm just left with theta equals sine inverse of 3/4. I'm going to go ahead and use a calculator to do this. Now I have a little online TI-84 calculator that I'm going to share screen with you so that we can do this together. Now a couple of things. First thing you need to do is think about your mode. This problem said theta is in degrees. So the first thing I'm going to do is I'm going to go into mode and I'm going to double check. Yep, my degrees. So I have degrees versus radians here in the little blinking area. I want degrees. Degrees is highlighted. Now I'm going to go second, quit. Okay. So now I know that I'm dealing with degrees, which is what I want. And I'm going to find my inverse sine. So inverse sine right here, sine to the -1, same thing as arc sine, is right above my sine button. So I'm going to do second sine. That gives me, notice, inverse sine of 3/4. Close my parentheses, and I get an answer of 48.59 blah, 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 blah. Okay, so 48.59, I'm going to write that on the board and we're going to talk about it. So we got an answer of theta equals 48.59. Now the first thing we're going to do is notice that this says round to the nearest 10. So we need to round to the nearest 10. So that gives us 48.6 degrees. Now that's not our whole answer. Why not? Well, here's why not. It says find all the answers in 0 to 360 degrees. Okay, so here is the problem, all right? 48.6, that's great. That's one of our answers. So think about what I mean by this. If we're looking at a unit circle, right, in general, there are 2 places where sine has the same value. We think about something common like sine of theta equals 1/2. Well, that's going to happen in 2 different quadrants, right? Sine is positive in our quadrants 1 and quadrants 2, so we're going to have 2 answers, one in quadrant 1 and one in quadrant 2. So how do we get the other answer? Sorry, got interrupted there. So we were saying that one of our answers is 48.6 degrees, or approximately 48.6 degrees. But we want to find all of the answers kind of in a full circle, from 0 to 360, okay? Now, if we think about sine repeats. So what I want to do real quick is look at the unit circle and see if we can figure out that pattern here. So on our unit circle, right? For example, when is sine 1/2? Well, sine is 1/2 here at 30 degrees, and also here at 150 degrees. What do you notice about 30 and 150? Anything? Let's look at another example. So where is sine square root of 3 over 2? Here at 60 degrees, and also here at 120 degrees. Anything special about 120 and 60? Well, you may or may not have noticed, but those are supplemental, 30 and 150, 60 and 120. Again, square root of 2 over 2, square root of 2 over 2, those values of sine are equal. And notice that 45 and 135, also supplementary, sum to 180. Okay, so when we have an angle in the first quadrant, and our given angle, 48.6 degrees, is in the first quadrant, to find the other angle, the angle that goes with it, we're looking for a supplementary angle. Okay? So to find the other angle that answers this question, we can find the supplement of 48.6 degrees. Okay, so what's the supplement of 48.6 degrees? Well, supplement means sums to 180. If I do 180 minus 48.6, I'll get my answer. 180 minus 48.6 is something 0.4, but you know what? I'm gonna use a calculator to do that. So that's 131.4 degrees. So we have two answers, 48.6 and 131.4 degrees. Those two angles between 0 and 360 will give us sine of theta equals 3/4, or fairly close to that, because remember we did do some rounding in this problem.